Hello guys, welcome back to Maison African Motives. Still working on our engineering science info. In this platform, we are just going to have an introduction that we are going to focus on the relative velocity concept. Given maybe you've got two objects that you are to consider. What is it exactly that we are supposed to have? Just want us to have to relate in this case to, let's say, we are given a condition of working with the A's velocity. So we can refer to the velocity of A, just a certain object that we are referring to. So this velocity being taken with respect to another object. So we are going to have this with respect to another object. Let's just say to another moving object in this case. All right, another moving object, which we can just consider as B. Let us just say we are having another object which is B, which is moving. So the condition is for us to have or to calculate the velocity, which is the relative velocity, because we are considering two objects in this case, A with respect to another moving object, which is B. So in this case, we are simply saying the object A is taken with relative to the velocity of B, which is simply with respect to the velocity that is going to be considered at B. So this B, it's a moving object, meaning to say we are going to have a certain velocity there. Remember, velocity is simply the displacement over the time. So since this is a moving object, that means we've got a velocity that is going to affect. So on a condition that we are to calculate in this case, the velocity that is considered of A with respect to B, we are going to be applying the horizontal components. I want us to focus on the method of horizontal components so that we'll be able to understand. But the condition, whether it is of another method, the most important part are the steps that you are supposed to take. In this case, like I said, we are going to be considering our components. We've got horizontal and we've got the vertical component in this case. All right. So what is going to happen is that we are going to stop the object that is the moving object, which is taken, remember we are saying with respect to, in relation or relative to. So we are going to stop this object that is moving in this case. All right. So let us say the other object, which is the moving object in this case, our moving object, which is B, must be brought to rest. All right, must be brought to rest. So this is what you're going to consider, must be brought to rest. What am I trying to say? If an object is moving, now it is brought to rest. It means we are no longer having a movement in this case. There is no longer a movement, which means the object is actually, it has stopped. So this object must stop. Or the object is at hold in this case, meaning to say it has stopped. So how do we consider this object to be brought to rest? Or what can we consider to stop the object or to hold the given object? All right, this is considered, or this is obtained by turning it around. That is, we are going to reverse the velocity that we are having. So this, let us just say by turning it around, by turning it around and adding the velocity. So we are going to add the velocity to A and adding it to that of A. So that will be the condition that we are going to consider. We are talking about A in relation to B. So we are going to stop the moving part, which is B. This is just changing its direction. That is the condition there, changing of the direction. That is by turning it around. We are simply changing its direction and add now the velocity to that of A. So this, we are going to see it in consideration or in our questions, but let's just say we have got a continuum. We shall see in working with the actual questions so that we properly understand. If A is moving in this direction, which is the original object that you are given, and B is taken in this direction, the moment we are considering A in relationship or in relation to B, it means B is the one that is to be affected. So according to this part, I'm saying we are going to stop this, or we are simply reversing this object. So we're going to see the object B no longer in this quadrant, but we're going to have our B in this quadrant. So now you can consider your components with the angles taken. In this case, the angles, you're going to take them depending with the knowledge of your quadrants or the application of your components. But it is best, since we are to add these velocities, it is best for you to take your angles going in the anti-clockwise direction, and everything taken in the anti-clockwise direction is a positive. I'm not saying you can use this direction. I'm not saying it's wrong to use this direction. No, I'm saying it is best so that you maintain everything being positive, because the moment you take your angles in the clockwise direction, from our mathematics, we know that those angles, they're taken as negative angles. So that's why I prefer you to take in the anti-clockwise. We shall see as we're answering the questions. One and the same thing. So meaning to say B will no longer be in this quadrant. For our calculation, we are no longer going to have B on this side. We are going to have our B now transferred, because we have changed this point. So we're now going to have our B in this quadrant. We find our components, and from our components, if we have got the horizontal and we also have the vertical component, it follows that you're supposed to understand your quadrants, how each part is going to give us the result. And in the first quadrant, we are going to have this as, remember, that's our horizontal component, this one, meaning to say we are talking about being to the east or being to the west. That is what we are simply having. In terms of signs, we are simply talking about the horizontal being a positive or being a negative. Then we are going to be talking about the vertical component in terms of being in terms of the poles. This is going to be the north, and this will be the south. But in terms of the sign, this is simply a positive and this is a negative. So meaning to say, in order for you to end up in this quadrant, it means your vertical component, this one, must be positive. The horizontal component must also be positive. That is where we can end up having this quadrant, where this is your direction. Remember, this is your horizontal, this is your vertical. You are supposed to calculate the resultant there. So each and every quadrant that you're going to have, it is going to be determined by the components that you calculated. In this case, in order for you to have your triangle in this quadrant, what does it mean? It means your vertical component was a positive vertical here on this on top above the x-axis. It's positive. But the horizontal is the one that was negative in this case. If you consider our horizontal part, it is the one that is a negative. So meaning to say, we are going to consider our theta in this case, this being our resultant. This is our negative or horizontal, positive vertical. If your triangle was going to be in this quadrant, what does it mean? It means from our condition, the vertical was a negative. It's now down this side. So the vertical was a negative. The horizontal was also a negative. So that is the condition that can end up as having our triangle in this quadrant. We are simply taking from our trigonometry, from our mathematics. In this case, in order for you to have your final diagram from your components, it's because horizontal component was positive, vertical component was a negative. So this will end up in the fourth quadrant. So all these quadrants, or the presentation of these triangles, we are taking them from our mathematics, but you are taking from the result, from the components that you calculated. You calculated the horizontal component, you get your answer as a negative. You calculate your vertical component, you get your answer as a positive. You are supposed to consider, okay, which part am I going to have? Is it going to be in the first, in the second, in the third, or in the fourth? Where do we have our horizontal component being a negative, or because of being negative, it means we are at the west, or where are we having the west and the vertical component being a positive, meaning to say we are talking about the north? Where do we have these two? In which part are we going to have the west and the north? We are talking about this quadrant, that is the one that consists of the west and the north. So we are considering this quadrant. So meaning to say our triangle is going to be like this, where we are having the horizontal being a negative, vertical here being a positive, the vertical part, or west and the north part. So the triangle that gives us the direction and the velocity is obtained from the horizontal and vertical components. So this part I'm explaining because it's the one that matters the most. So let's see, what am I trying to say with these components? How are we going to apply the, all right, the other thing also from our science N3, we talk about the components. If you are to use these components to find the resultant, in this case, our resultant is going to be the square root of the horizontal component squared plus the vertical component squared. In order for us to find theta, we've got opposite and the adjacent. So theta is going to be arctan, the opposite, which is the vertical component, over the horizontal component. And the sign that is there simply indicates the direction. So you don't consider the sign, just take your values as positive. It's not an effect. So let's try and figure out using this issue of components to find typical, or to solve some typical questions. This is a question that we are going to focus on from the question paper of August 2016, where we are given two vehicles start moving simultaneously at a flock of a rod. So we're given two vehicles simultaneously, that is at the same time. They are taken from the same point, in this case from the flock of a rod, moving simultaneously, that is at the same time. So let's see how these vehicles are moving. Vehicle V travels at a speed of 125 kilometers per hour northeast. All right, so let's consider our vehicle. This is our north, our south, our west, and this is the east. So northeast is between the north to the east, from the north to the east. So meaning to say we are talking about in between. And whenever it is northeast, it is taken at an angle of 45 degrees. It's in between 90, so you divide by 2. So meaning to say we are moving from the north to the east like this. There's an angle there of 45 degrees. This is our vehicle V, which is at a velocity or at a speed of 125 kilometers per hour. Then we have got vehicle W, which is traveling at 125. So it travels at 125 kilometers per hour directly to the east. Take note, it's moving direct to the east, meaning to say we are direct in this east line like this. So this is where we are going to have the vehicle W in this case. So this is our vehicle. So this W is for the vehicle, which is moving at a same speed, just like our vehicle V, which is at 125 kilometers per hour. So these two objects, they have got the same speed. It can be like that, but they are taken from different points. This one is taken directly in the east line. Take note, is taken directly in the east. This one is taken between north and east, northeast, in between the north and the east. So the question here is the most important part. Calculate the velocity of the vehicle W. This is part. Relative to the velocity of vehicle, relative to, we are considering to this object, which is V. That is the most important. Relative to which vehicle are we considering? We are considering V. So we are going back to this part where we are talking A being taken with respect to the moving object, which is B. What is going to happen? You are going to bring the object that is moving to the rest. That is simply turning it around and add the velocity. So we are going to turn around what is relative to. It's relative to what? To V. V is the part that is important. So we are going to turn around this V. Simply, we are going to change in this case, the direction of V. V is moving in the northeast direction. So we're going to have this, it was like this. So we're going to have this going the other way, that is to reverse. We are simply reversing this part. All right, so let me show you how to reverse from this diagram that we are having here. Remember, it is in the northeast. So we are just going to have this as a continuation this side, but let us have it now going this direction. So let us just have a similar sketch that we are going to use in this case, so that we do not confuse from the actual diagram that we have. This is our north, we've got our east, west, and south. So previously we were having our object this way. This is where we are having our object. Now it is going to turn around. It was facing this direction, so now it's going to go the other way. So we are going to have our object in this direction. That is where we are going to have what? Our object in this case. So the direction is changed in this case. This is the most important part. We are now having our direction this way. So meaning to say, we are going to consider to say this is 45, because here we are having 90 degrees. So 90 minus 45 means say also here you've got 45. And from the concept of our angles, we understand that these are vertically opposite angles. So in between here, there is an angle of 45 degrees. From our vertical angle concept, this angle is going to be 45 degrees. But this is not the angle that we are to consider. Remember, I said the easier concept that you can consider is to take your angles in the anti-clockwise direction and you simply add them together. So meaning to say, taking this from the positive horizontal axis, all angles taken from the positive horizontal axis in the anti-clockwise direction until we meet this line here. We are going to be considering 180 of a straight line plus this 45. So we are going to have 180 plus 45 degrees. We are now taking it from our mathematics there, the concept of quadrants. So this is going to be 225 degrees. All right, so we have reversed the V in this case. It's no longer where it was before. We are now having our V at this direction here. So this is our V, which was at 125 kilometers per hour. What is relative to this one that we are affecting? In this case, if it was a condition that W is the one that is, it's a V with respect to W, we're going to change or we're going to reverse W, but it's W relative to V or with respect to V. So you change V. Meaning to say the W is going to remain as it is. This object here or this guy is going to remain where it was along the east line. So we are going to have this along the east line. It is not going to change. We are going to have it along the east line. So this was our W in this case. So we've got our W at 125 kilometers per hour. So that is what you're going to have. And along the east line, this is at 0 degrees. Remember our angles taking in the anti-clockwise direction. It is going to be 0, 90 degrees, 180, 27, and so on. So we are now working with an angle of 0 degrees for this velocity of W. For V, velocity of 125, the angle that is going to affect is the whole of this angle in the anti-clockwise, which is 225. So that's the easier part, that at least maybe you can understand this topic. And once you have got these angles, you are done. Move on to your diagram. Move on to your calculation of the components. So the horizontal component, remember, it uses the cosine of theta. So we are going to have the W, which is 125 cos 0 in this case. So we've got 125 cos 0 degrees plus everything is added. All right, we move on to this 125, the angle affecting, which is the whole of this angle from the positive horizontal axis. So we are going to have 125, the cosine of 225 degrees. All right, so that's it. We have got our horizontal component in this case. So this was going to give us 36.61165. So this will be a 2 in this case, all right, in kilometers per hour. The same thing as I am saying here is going to happen on the vertical component. We are going to apply the same, change that the cos into a sine. So this will be 125, the sine of 0 degrees, then here plus 125, the sine of 225 degrees. So we have the vertical component in this case, okay? So if we calculate our vertical component, it is going to give us a negative 88,388 in kilometers per hour. That one was going to be a negative. So now the concept is this is where I was explaining, after calculating your components, the horizontal component, the vertical component, that's where you're supposed to calculate the velocity that they are referring and the direction. We need the magnitude and also the direction. So this is the diagram that I was explaining to say you have to consider which quadrant are we working, which quadrant are we going to consider according to where, according to the values or the positive or negative sign that you're having on the horizontal and also on the vertical. So we are now back to this, then you can apply your formula. So let's check which quadrant are we going to consider. Being horizontal and being positive, it means we are simply, remember this is horizontal, we are simply to the east. So this is simply to the east. Being vertical and negative, meaning to say you are simply going down, which is to the south in this case. All right. So at the end, we are going to have this represented this way. We need a condition where we are going to have these poles. All right. So all right, so let's just indicate this way. This is the most important part, the North Pole. Then we've got south and our west and our east. So where are we going to have the east and the south? So the east and the south will be found in this quadrant. That is where we are going to have it. Or where are we having horizontal being positive, vertical being negative? It is this quadrant. So that is where we are going to have our triangle in this case. So you have to consider with the sign that you are obtaining, or to say which side is it, east. So I talk about the east and the south. It's a negative here. All right, so this is our horizontal component here, which is, or even the sign is not important. So you can just write the value as it is, 36.612 kilometers per hour. And the vertical component, this is the vertical line. All right, so we are going to have this, our vertical component of negative 88.388 kilometers per hour. So that's it. You calculate the resultant, which is the velocity and the direction. So the direction now is going to be considered, if you consider inside this, is going to be between, because it's between the east and the south. So we are moving from the east going to the south, or it's either you can move from the south going to the east like this, meaning to say you are supposed to calculate this angle, which you can refer as alpha. So for the direction, there are two answers that you can write there. So it's up to you. If you consider this one inside, you are moving from the east going to the south. That is from this horizontal to the resultant. You do not move from this point like this, like in between. You may have to start from a pole, which is from the east, or you are starting from this pole, the south pole, going to the what? To the east. So that is the most important part on your calculations. All right. So like I said, the resultant, as we are at this stage, guys, to find the resultant there, which is the velocity, is simply the square root of the horizontal component squared plus the vertical component squared, where r is equal to the square root of the horizontal, that's 36.612 squared, plus the vertical, which is negative 88,388 squared. So that is going to give us the resultant in this case. So if we are to consider this part, we were going to obtain 95,671 kilometers per hour. So that is what you're going to obtain from your calculator. So with this value, yes, you can use it if you want to calculate theta, but because of this, it's a value that you're calculating from another value. So it's best for you to use the original values that you are given that we calculated before, which is the vertical and horizontal, to calculate theta. So theta, like I said, is simply arctan, the vertical component, which is our opposite over the adjacent. Remember, the tan of theta is equal to opposite over adjacent. So in order for you now to find the theta, is going to be arctan of the opposite over adjacent, which is arctan, the opposite. So the sign there is just to indicate which quadrant are we in. So when you are calculating this sign is not important. Just use the value as it is, which is 88,388 0.88 in this case over the horizontal component, which is at the adjacent of 36,612. So that is what we're going to have. So you can calculate your theta, which was going to be 67,49972. So this was going to be 67,5. This was going to change until a 5 years. So we've got 67,5 degrees. That is our theta. We are now talking about the direction. So like I said, for the direction, it is important because we've got two ways. It's either we are moving from the east to the south or from the south to the east. So if we are to consider moving this theta, as I said, it is from the east, theta degrees to the south. We are moving from the east to the south. So meaning to say, we are going to have this as east, the angle now, which is our theta, 67,5 degrees to the south. But let's say we wanted to consider it in terms of the alpha moving this way. It means we are moving from the south to the east. We have to calculate alpha from 90 degrees. The whole of this angle here is 90. So meaning to say alpha. So, all right, so this is another way. So, or we can calculate alpha there. Alpha, which is simply 90 degrees minus theta, because these two angles, they add up to 90. And our theta is 67,5 degrees. So we're going to obtain alpha from there, which was going to give us 22,5 degrees. So we have the value of alpha. So if you were to refer it in terms of alpha, it was going to be south alpha degrees to the east. So we are going to have this as 22,5 degrees going to the east. Now we are moving from the south to the east. So it's going to be 22,5 degrees to the east in this case. All right. So that is how we can present these guys. As you can see, we all we just need in this case is to have our components from the actual diagram that we have. You have to redraw the diagram in with the reversed. What is with the relative to? We have to reverse that, calculate your components from the concept of finding our angles, which are taken from in the anti-clockwise direction from the positive horizontal axis or from the east in the anti-clockwise direction. So we can just have now a conclusion of these two. It's either you're going to write it in words or you're going to just write it in short. If you have to write it in words, thus in this case, we are going to conclude that the velocity of W in this case, that was relative to, remember, it was relative to the velocity of V relative to the velocity of V in this case is going to be given as the velocity here and the direction. So we've got our velocity, which is at 95,671 kilometers per hour at now you can consider the direction, which is east, 67,5 degrees to the south, or maybe you want to express this way, meaning to say you are going to write it as south 22,5 degrees to the east. So it's up to you, but that is what we're supposed to actually have in this case. So if you're to consider this method, you see that it's a direct method or it's a direct application that we are having. The only important part is on this diagram here, which is to consider your components. Remember, you're working with components. So components from our science N3, I'm not going to limit you to only this method or to only taking them in the anti-clockwise. No, do whatever or calculate in whatever way that you understand, but you are supposed to have the exact same way or same application as the one that we are having here in terms of our answers and in terms of the resultant at the end, which is the velocity. So like I said, this we can just write it also in short here. We could have just presented the velocity of what W relative to that of V. We can just write it in terms of the velocity. So we've got W relative to V in this case, all right? So we can just write it in short like this, or you can just write it in words, which is one and the same thing. Let us consider another question in this case. This is August 2018, where we are given two vehicles moved simultaneously. Vehicle P moves at 220 east, while we are given vehicle Q moves 220 kilometers in the direction of west, 30 degrees to the north. All right, so these two vehicles are, like I said, they'll be taken. So in this case, I hope now we understand, which I'll have quick this one in a quicker way. So this is our north. All right, so we've got our north, our south, west, and east. So Q is in the east, so meaning to say we are going to have our P in the east like this. So this is our vehicle P, which is moving at 220 kilometers per hour. All right, then whilst Q it's at 220 against same velocity, then it's west 30 degrees to the north, from the west going to the north in this case. So we're going to have this in this quadrant. We're going to have in this quadrant here, moving from the west going to the north like this at an angle of 30 degrees. All right, so that was going to be our vehicle Q in this case, which is also at 220 kilometers per hour. All right, if we are to consider what I said, remember we are told calculate the velocity of vehicle, calculate the velocity of vehicle P relative to Q. Take note what we are considering, relative to Q, Q is the one that we are supposed to stop and change, that is to simply change its direction. So we are supposed to have our Q reversed now in this direction. So that is where we're going to have our Q at the end. So instead of having this Q the normal way that it is, we are going to reverse it like this. All right. So that is now we are having our Q this way. Remember the concept of our vertically opposite angles. If this angle is 30, this is also 30, and here it's 60 degrees on this one. So it means also this is going to be 60 degrees. So this is going to be our Q. We have reversed what is in relative to, we have to stop that Q that is simply reversed. So meaning to say we are no longer having our Q here like what we saw in the previous case. We are no longer using this Q. This was just for the reference in order for us to obtain the actual diagram that we are going to use. So we are now given here to calculate this. So from this part that we are having, that is where I said if you are to use the components, take your angles in whatever way. So as for me, I'm going to take it in the anti-clockwise. P is at 0 degrees. What about Q? Take this angle in the anti-clockwise direction until we meet this line. That is, we are going to meet this line. So what is going to be this angle? Let's consider our angles here. Remember, this is 0, 90 degrees, 180 degrees here. Now we are at 270. This is 180. This is 90 here, 180, 270. So 270 plus 60, we just have to add this 60 because here we are at 270. So if we add 270 plus 60, this is going to be 330 degrees. So meaning to say the angle that we are going to consider, the whole of this angle is going to be 330 degrees. All right, so we are going to have this angle as 330 degrees. This is the angle that we are going to use for Q. Not to say we can't use any other angle. No, you can use any other angle, but know how to apply those angles in terms of the sign. You are supposed to know what to do in terms of the sign. Once you have got your diagram, remember we reversed our diagram, now is in this quadrant. So we are going to have our components. So the horizontal component was going to be simply P, which is 220. So we've got 220 cos 0 degrees plus this 220 for Q. So we've got 220 cos the angle in this case, which is the angle of 330 degrees. So this is taken at 330 degrees. So that's our horizontal component in this case, which is going to be 410, 558. So it's going to be 526 in this case. All right, kilometers per hour. So we're going to have, remember the other units here were kilometers per hour. So this also must be in kilometers per hour. All right, so that's the concept. Now do the same thing for the vertical component, just use sine here. So you're going to have 220 sine of 0 degrees plus 220 sine 330 degrees in this case. All right, so we've got our vertical component from this calculation, which is going to give us a negative. So it was going to be negative 110 kilometers per hour. So with the horizontal component, vertical component, remember horizontal being positive. If a horizontal is positive, it means we are going to the east, horizontal positive. Vertical being negative, it means we are going down, meaning to say we are considered to the what? To the south. So which quadrant are you going to have east and south at the same time? So if you are to consider this, we are going to see that the east is here, the south is here. So we are going to have this in this quadrant. It's actually by coincidence what happened here to say this quadrant where we are having this diagram, like is where we are also having this. No, it can be from this, then we have our diagram in this quadrant. No, this one is just a coincidence. It's not like we are taking from this one that was there already. No, we are going to have this diagram from the components, from the horizontal and from the vertical components, this one. So we have got horizontal being positive, which is to the east, vertical negative to the south. So our triangle is just going to be the same as that one that we got in the previous question. We are going to have our triangle in this quadrant where we are going to have our theta, or we talk of alpha. So that is the concept. This is our horizontal, which is going to be 410,526 kilometers per hour. And we've got the vertical being a negative. So as you can see, it's just the same as the last question that we had at the end. Then we can calculate our r, which is the velocity. So the velocity, which is like our resulted r, is going to be the square root of the horizontal component plus, or you can even start with the vertical as we saw. So it's going to be 410,526 squared plus the vertical component squared, which is negative 110 squared. So this is going to give us r, which is the resultant. So that was going to be 425, 00776. If you are to round this to 3 decimal place, we are going to have 008 in this case. All right, so that's kilometers per hour. So that was going to be the velocity, and the direction which can be taken from either theta or alpha. If you are taking from theta, the angle that is inside here, theta is going to be arctan, the opposite in this case over the adjacent, which is vertical component over horizontal component. The negative, like I said, is just for the direction, so don't consider that. So it's going to be 110 over 410,526. So that's it. We are going to have our theta, which was going to be 14,99998 and so on 8. So as you can see, changes this 10, 10, 10. So it's going to end up as 15 degrees. So that was going to be our theta. In order for us to find alpha, which is this one, in terms of our direction, like I said, there are two. So if you are to consider theta, it means we are moving from the east to the south, east going to the south. This is where we have our theta. So it's going to be east theta degrees, which is 15 degrees to the south. But if I had to consider from the south going to the east, it is going to be, or we can just write this as, or we are going to have a south alpha degrees to the east. So it is going to be south, you subtract 15 degrees from 90 degrees, this one. So it's going to be 90 minus 15, which will be 75 degrees. So you have to subtract 90 degrees minus 15 degrees. You're going to obtain 75 degrees. So it's from the south going to the east. So this one is another way, or that's why I'm saying, or it's another presentation or another direction that you are going to use, or that you are going to apply in this case. So you can just conclude now, because we've got two directions that you can consider. This one is your choice. Like I'm saying, it's your choice. So let us just have this into conclusion. Like I said, you can write this in words or so forth, depending with what you want. So it was P relative to Q. So it was P relative to Q. So let us just have it here. So we're gonna have the velocity of a P in this case relative to Q, which was going to be 425.008 kilometers per hour. Then the direction in this case at east 15 degrees to the south, or you can use this one, it's up to you, all right? Or you can write in words the velocity of P relative to velocity of Q is in words. All right, so that's it. As you can see, guys, let us quickly have another question. Also, there's another question that I want to correct. I think it's this one. Yes, April 2023. Yes, I just want to have a correction there. We did this with another method, and there is something that I did not consider on the direction at the end. So let me just please let me just correct it and pardon for that mistake that happened in that video. So we're given in this case here, two ships, they leave Cape Town simultaneously. So we've got ship A sails in this direction, northeast, and B south 25 degrees to the west. All right, let us take these two ships which are moving from the same point. All right, so they are moving from the same point. We've got our North Pole, south, west, and east. So the first one, which is ship A, it sails at a velocity of 125 kilometers per hour in the direction, take note the direction, northeast. The part of this direction was fine, so you're just gonna take this northeast. Remember I said it's in between the north and the east, meaning to say it's taken at 45 degrees, 45, 45. So we're moving from the north to east at 45 degrees in this case. So this is our A, at which velocity? 125. Take note, A at 125 kilometers per hour. All right, so that's it, 125 kilometers per hour. Then B sails at a velocity of 92 kilometers per hour in the direction of south, 25 degrees to the west, from the south to the west. So we are moving, in this case, south to the west. That is the direction that you're supposed to consider. So it's supposed to be somewhere here. All right, so that is moving from the south, going to the west. We've got 25 degrees. That was exactly what you're supposed to have. Okay, let's see. This is our B at 92 kilometers per hour, 92 kilometers per hour. So the question in this case is to find or to calculate the magnitude and direction of the velocity of boat A relative to boat B. Take note, boat A relative to boat B, relative to this one. So we are supposed to stop B. That is the concept. We are supposed to stop the B in this case. So how is this going to happen? All right, let us see the first part here. Northwest. All right, now I'm having something which is wrong here. Northwest, not northeast. I hope someone, because now I'm wondering to say, why is this now in the same quadrant? All right, this is northwest, like this, northwest, going from the north to the west. All right, so I'm trying to correct another correction, bringing another mistake again. All right, you see these things, guys, how do they happen? All right, anyways, take note, this is ship A at a velocity of 125 in the direction northwest. Please, guys, let us just correct this. So it's 45 degrees at 125 kilometers per hour. This is our vehicle A. All right, so the condition is we are given to calculate the magnitude and direction of the velocity of boat A relative to boat B, relative to B. So we have to stop B in this case. That is, change the direction of B, add to that of A. So B was in this direction. We're going to change each direction. We are going to see B now this way. This is where we are going to see our B. It has to change the direction so that it can be added to A. It can be added to A. what is relative to. So we're going to have our diagram at the end like this. All right. So that's it. This is where we are going to have our B now, which was at 92 kilometers per hour. What about the angle? Remember our angles, like I said, they are taken from the positive. So you need this angle that is in between here. And this angle is the same as this angle here, vertically opposite angle. So how am I going to find this angle? That is the question now. How am I going to find this angle here? We are simply going to calculate this angle. From 90 degrees, 90 minus 25 degrees, which is going to be 25, 90, which is going to be 65. And so that's a 65 degrees. We are having 65 here. So if this is 65, then it means also this is going to be 65 degrees. We are done. We are done at this stage. This is the most important. This part is no longer important. This one, it just helped us to find the part that we are going to use. Yes, you can use it where it is, as long you know how to use your signs. And I think I'm just going to have this as a separate video so that we do not have confusion. I want you to stick to one thing so that you do not have confusion. So if you want to use the negative, like I said, we are going to have this as a separate video so that at least we can understand how to change the sign to a negative. You can, that it must remain in that quadrant in order for you to apply that. So we are going to talk about that. But using this, you're simply going to change and other. Then you take everything as it is as positive. So this will be positive 65. What about A? A is not going to change. We are simply going to need the angle. Remember, from the positive horizontal axis, that's where we are taking our angle. So we're going to take the whole of this angle here. This is the angle that we want. So remember, this is 90. 90 plus 45, that is 135. So this whole angle is going to be 135 degrees, which affects A. So A is affected by an angle of 135 degrees. So let us find our comp. We are done. We are done at this stage. We just need our components now. So the horizontal component is going to be 92. Cosine of 60. So we've got cos 65 degrees. Then 125 plus 125, the cosine of 135 degrees. So we're going to have cos 135. So that's, we've got our horizontal component, which was going to give us negative 49,507 in this case, okay? Kilometers per hour, which is being a negative, it means we are going to the west in the horizontal. So this is going to the west. We move on to the vertical component. We just have to use sine here. So it's going to be 92 sine 65 degrees plus 125 sine 135 degrees. We combined everything. So that's our vertical component, right? So our vertical component in this case was going to give us 171,76866, which is going to be 769 in kilometers per hour. So we have calculated this vertical being positive. It means we are going up to the north. So we have got the horizontal component. We also have the vertical component. In this case, we have our components, horizontal and vertical. Which quadrant? That is the question. Which quadrant are we going to consider, or where are we going to have our resultant in the velocity? Where are we going to consider? Which quadrant are we going to consider where these two, where are we going to locate these two? Where we have got the west and the north, the west and the north. In which quadrant? Let us have this. All right, so this is our quadrant part. This is our north and this is our south, west and east. So where are we having west and north? So west and north is considered in this quadrant. Or where are we having horizontal being negative? It's here. Vertical being positive, it's here in this quadrant, here in this quadrant. So remember, from our triangles in this quadrant, our triangle is going to be like this. This is where we are going to have our quadrant, where the horizontal is a negative 49,507 kilometers per hour. The vertical being a positive. This is our vertical here of 171,769 kilometers per hour. And this will be our direction theta. or we can consider it from the north to this direction, which is alpha. So this is our R here. So that was what we're supposed to have. So especially on the direction there, I want us to correct, because that part, there's a part that I did not consider on finding the direction there. So please just forgive me for if you're using that concept, and it need to be corrected, actually need to be corrected from our previous question of this same paper. All right, so now our resultant, this one is just one and the same as that part. It was not affected. So it's going to be the square root of the horizontal squared, which is negative 49.507 squared, plus the vertical component, which is our vertical component here, which is 171, comma. So we've got 171.769 squared. So that is going to give us the resultant in this case, which is the velocity of 178.7611, which is 761 kilometers per hour. Okay, so that's our velocity. Then the direction, like I said, you are considering two things, or two ways in this case, from the theta or from the alpha. If you are to consider from the alpha in this case, or from the theta, I mean this theta is from the west going to the north. From the west, this to the north. This is where we are having our result, our direction here. From the west, we start from a pole, not in between the pole, from the west to this. So it was going to be west theta degrees to the north. So we have to calculate theta, where theta is taken from arctan, opposite over the adjacent, where this is our opposite, this is our adjacent. So opposite 171.769 over the adjacent, which is going to be 49.507. Remember, I said the negative is already, it's already taken. We have already used this negative in order for you to have this triangle. It was because of this negative. So you don't consider it when calculating here. We just need the angle as it is. So our theta was going to be 73.922. All right, so that was going to be 73, sorry for that, 73.922 degrees. So meaning to say, in terms of the direction, we are simply saying it's the west, theta degrees, which is the west, the angle, 73.922 degrees to the north. The direction there is to the north. Okay, if I had to consider this part here, this direction, it means I'm moving from the north. The pole that I'm using in this case, the pole that I'm starting from is the north, going to the west direction. So I can consider this as, or we are going to have this as from the north going to the west, which is alpha degrees to the west. So that means I have to calculate the alpha. So that is going to be north alpha, which is subtract this from 180 because from 90, because this whole angle is a 90 degrees. So 90 minus 73.922 degrees in this case. If we subtract, we are going to obtain 16. That's 16 in this case, 16,078 degrees, which is we are moving from the north to the west this time, from the north to the west. So that will be the direction there, from the north to the west. So that's what is important. Then you conclude at the end. You have a conclusion. Remember, the question was the velocity of A with respect to the velocity of B. Let's just confirm. Relative to that of both B. So it's A relative to B. So if you are considering A relative to B, it means we are going to have this as the velocity of A relative to B, which is going to be 178, the speed or the velocity there of 178,761 kilometers per hour. Then the direction, we have got west 73,922 degrees to the north. Or you can apply this from the north going to the west. It's one and the same thing. You're simply referring to the same point, same location. So I just want us to correct that question, please, so that it can help us in our revision. That's why to bring also this question as we are revising so that we can correct that our question. All right, 2 cars from this one, November 2020, are given 2 cars. They leave a fork in the road, simultaneously. Then we've got car X at 60 kilometers per hour to the west and car Y traveling at 100 kilometers per hour in the direction north 45 degrees to the east. Calculate the relative velocity of Y with respect. All right, so let us quickly have this one. I think now the concept is in the head. We now have a clue of what is happening. This is our north, south, west, and east. So let's start with X. X is 60 kilometers to the west. So this one is moving direct to the west, direct in the west line like this. All right, direct in this line. So that's our car X. So we have got our car X at 60 kilometers per hour. All right. Then Y travels at 100 kilometers per hour, north 45 degrees to the east. Instead of them writing northeast, you see how they can write the same thing, northeast, the same northeast that we know. They can write this way because remember, northeast is between 45 degrees. So it's the same. They're just writing in the northeast direction or north 45 degrees. So in this case, they gave us the angle, which is fine for someone who might have forgotten for northeast, maybe you've forgotten the angle. Here it was just an advantage that you're given the angle. So this is 45 degrees. So that's Y in this case. We've got vehicle Y at 100 kilometers per hour. So that's what we have. Calculate relative velocity of car Y with respect to X in magnitude and direct with respect to X. So X must stop, not Y. X is the one that is supposed to turn, and we add it to Y. So we are supposed to turn this X, we add it to Y, that is to stop X. So in order for us to, it's in the west, it's going to the west. So we are simply going to turn it this way. So it's going to be in the east. It was going this way, so it's gonna reverse this way. That is what I'm trying to say. So we're going to have this, our car X now in the east, which is at 60 kilometers per hour. Remember, in the east, the angle there, it's 0 degrees. So we are no longer considering this X that we had before. No. We are no longer having that. We are no longer having this. It is now in the east. We have to change its direction to reverse the direction. So that's it. And considering our components, like I said, our angles taken from the positive, the horizontal axis in the anti-clockwise, meaning to say we have to calculate this angle here, which is 90 minus 45 is going to be 45 degrees. So the angle here is 45. So let us calculate our components. From our diagram, we are going to have our horizontal component at 60 cos 0 in this case. So it's going to be 60 cos 0 degrees plus 100 cos 45. So it's going to be 100 cos 45 degrees. So that's our horizontal component in this case. Combine everything, we are going to obtain 130,7107, which is 711 kilometers per hour. So that's our horizontal component. We move on to the vertical component in this case, which is the same, just change this to sine. So we're going to have 60, the sine of 0, plus 100, the sine of 45 degrees. So as you can see, this is the easiest way of solving. So we just hope with time, I'm gonna come back again with another way of changing these into negative. If you want to use negative, but if you want to use positive, it is just to add everything, consider everything taken in the anti-clockwise direction, change the direction of what is relative to, then you take your angles in the anti-clockwise direction, you are done. So once you have got horizontal and vertical, as you can see, horizontal is positive, meaning to say we are going to the east. Vertical is positive, we are going to the north. So which quadrant are we going to have at the end? We are going to have this in the first quadrant. In the first quadrant, that's where we have north and east. So our triangle is going to be in the first quadrant. All right, so we are going to have this in the first quadrant like this, whereby our horizontal is positive, is to the east, and this is to the north. So we are going to have horizontal this side 130,711 kilometers per hour. The vertical, which is this one, which is at 70,711 kilometers per hour, we have to calculate our theta and the resultant, which is the velocity, and alpha here being another way of finding our direction. So that's it. So that's the concept, guys. All right. So let us find our r here, which is the square root, the horizontal component squared, horizontal component 130,711 squared plus the vertical component 70.711 squared. So you're going to have r in this case as 148. So that was going to be 148,612 kilometers per hour. Then we can calculate in this case our theta or alpha, which is now the direction. So for the direction, it's either we are going to have it's either we've got all right, so let's see, either we are going to have this way from the east. Remember, we start from the pole east to the north. So it is going to be east going to the north. So it's going to be east theta degrees to the north, or we can have this as from the north to the east. So it is going to be taken as from the north alpha degrees in this case to the east. That's another way. So let us consider finding theta, which is inside of the diagram. Inside of the triangle here, we can find theta from arctan concept, since we are given the opposite and adjacent in this case. All right, so that means our theta is going to be arctan, the opposite of 70.711. All right, so that is 70.711 in this case over. Okay, let's see, 0.11. Okay, let me change this one. Sorry for this, guys. That's a 1 there, all right, over the adjacent, which is 130,711 like this. So that was going to give us theta, which is 28,412 degrees. Okay, so we've got our theta. So in order for us to have alpha from the 90 degrees here concept, this is at 90 degrees. So we can obtain alpha from there. That's 90 minus 28,412 degrees. So alpha is going to be given as 61,588 degrees. So by obtaining alpha, it means the direction, therefore, is going to be given as what? All right, let's start by finishing up here. I see I did not finish here. East. All right. Theta degrees, which is 28,412 degrees to the north. All right, then here, alpha from this concept north, 61,588 degrees to the east. So that is another way from this one, or we can use it that way. So that is how we can answer this question. Let us just have a conclusion here. It was the velocity of car Y with respect to car X. So car Y with respect to X is going to be given as the velocity of car Y with respect to X, which is the velocity of 148,612. So we are going to have 148,612 kilometers per hour. Then the direction now, this one that we have to consider here, which is at east, 28,412 degrees to the north, or you can consider this one. All right, it's up to you. It's your choice. It's your choice, or you can write in words the velocity of Y relative to the velocity of X is, then you conclude everything. So I think if we are to use this, guys, we are not going to have any mistake. We are not going to have any mistake. That's why I had to bring this as a separate part and bring up questions so that we consider, we talk about these questions, we understand them together. And like I said, or like I have promised, that I'm going to come back again with time, let me just say with time, so that we talk about other ways, still working with our horizontal components, but we can change them to negative in favor of the diagram that you have, if you do not want to change that diagram. But in actual sense, this is what you're supposed to have from the actual method or the traditional method of these horizontal components, but you can change them to your favor of the diagram, which which can be done. So we have to see that part as time goes on. But for now, let us keep on revising towards our exams, which are ahead of time.